Cadence is also exhibiting here today at the Santa Clara Convention Center, and Susan here is going to be telling us a little bit more about what Cadence is doing and about the partnership with Global Foundries. Hi Susan, how are you doing?
I'm great. So go ahead.
So first of all, tell us a little bit about Cadence.
So Cadence is an EDA company. So we build design tools for engineers who are building systems on chip or chips that go into a lot of mobile devices and many, many other things.
And you guys have been working with the common platform now for a couple of years.
Oh, since its inception, actually. Our goal was to work early on in process development so that the new design rules that the manufacturers need in the tools, so that engineers get the right manufacturing result out in the end, are baked into the tools. So we have to make changes to the software tools early on while the process is being developed, so that we have our capabilities ready for engineers when the process is ready. So it's sort of concurrent engineering philosophy.
How difficult is it working with various, I mean, the common platform is obviously made up of various different companies, and I'm sure that they all have their own demands and requests. How difficult is it accommodating all of those requests and working with multiple companies within one platform?
Well, certainly each company has their own desired result. Some may have a different focus from another. So to a certain extent, they have sort of a common set of requirements that makes it easy that we can use that, develop that common set, and that's okay. And then we just build on top of that common platform, so to speak, to give each one of the partners their own specific required enhancements. And so it's not too bad, really.
So give us an example of some of the enhancements and some of the smart tools that you guys are developing.
Okay, so for the 28 nanometer process, some of the things that we've worked on is the design rules that we call in-design. The design rules that the process needs so that the traces that build the circuitry are of the right dimension and proximity to one another. That information has to be baked into the tools that route out the chip. Yep. And the traces on the design. And we needed to understand what those rules needed to be, starting probably, well, we started in 2008 for 32, and then we had to make the next set of enhancements over the 2009, 2010 releases of our tools to get those rules built into our routers. Now, what we had done in the past, before 2010, is that at the end of a design, the customer would have to run a DFM check. And in the early days, when there weren't so many difficult rules, you could just fix up the things that we found. But today, there are so many complicated rules because of the small process geometries. We need to get those fixed during design. And that's why we introduced a new capability called InDesign, which allows you to do the process checks while you're doing the design rather than waiting till the design is done to check for those problems.
Perfect. Well, thank you very much for explaining that to us, and I'm sure we'll run into you again at one of these conferences. Thank you.